For this video, we're going to look at more straight line questions, this time a little bit more in context and exam type questions. We're going to look at line of best fit, which is a line that's been drawn in the middle of a scatter graph, which shows a nice fit in between where the points are plotted. So I've taken this question, it's on the national5math.co.uk website. You can look there for a few more examples to try it after I've gone through this one. So this one says, the graph below shows the relationship between the history and geography marks of a class of students. A best fitting straight line AB has been drawn. Point A represents 0 marks for history and 12 marks for geography. Point B represents 90 marks for history and 82 marks for geography. Find the equation of the straight line AB in terms of H and G. So as we can see, we've got 2 points which we're going to write down first. So point A, which is 0, 12. We're just taking that from here, so 0, 12. And then point B, which is 90, 82. So point B. So the things that we need for the straight line are gradient and a point. We have 2 points here to choose from at the end, but we can also find the gradient because we have 2 points. So we can label these points x1, y1 and x2, y2. Just be careful when you're labeling your points, because if you go wrong here, that's you pretty much done. So m equals, and this is one of the equations you need to know, y2 minus y1 over x2 minus x1. So we write that down and then we substitute in our points. So the gradient equals y2 is 82 minus y1, which is 12, over 90 minus 0. So tidying that up, m equals 82 minus 12 is 70, 90 minus 0 is just 90, and so therefore m equals 7 over 9. And it's best to leave it as a fraction, especially because this is actually a non-calculator paper, so we wouldn't want to simplify that any further. So m equals 7 over 9. Once you've got the gradient, you can substitute into the equation. So we can use y minus b equals m brackets x minus a. Or for this one, because we actually have the y-intercept here, 0, 12, so we know exactly where it crosses the y-axis, we can just go straight into y equals mx plus c, which is going to be a little bit more straightforward for this one, because we have the gradient, which is 7 over 9, and we know the y-intercept, which is c. C is just 12 because that's where it crosses the y-axis. So we can write y equals 7 over 9x plus 12. Now we're not finished there, and this is one of the things you need to be really careful of, because it does say in the question, find the equation of the straight line AB in terms of H and G, and you could have just done all this work and then lose the final mark. So we just need to replace y and x here for H and G. So instead of y, we look at what's on the y-axis, and it's g. So instead of y, we're going to write g equals, so 7 over 9 is still the same. X in this context is h, so we're going to do 7 over 9h plus 12. And that's you finish there once you've got to that point. Okay, we're going to look at another past paper question. So again, this is a line of best fit. This says, a cattle farmer records the weight of some of his calves. The scatter graph shows the relationship between the age, A months, and the weight, W kilograms, of the calves. A line of best fit is drawn, so we can see that there. Point D represents a 3-month-old calf which weighs 100 kilograms. Point E represents a 15-month-old calf which weighs 340 kilograms. Find the equation of the line of best fit in terms of A and W. Give the equation in its simplest form. So we're doing exactly what we just did before. So point D represents 3 100. So we're going to do 3 100. And point E here, sorry, is 15 340. So we label it again. x1, y1, x2, y2. 2 points so we can find the gradient. Gradient equals y2 minus y1 over x2 minus x1. Substituting in, y2 is 340, y1 is 100, x2 is 15, and x1 is 3. So we have 340 minus 100 on the numerator, so that's 240 over 15 minus 3, which is 12. And we can do this, 240 divided by 12 is actually going to be 12 goes into the 24 2 times and 0, so the gradient is 20. Once we've found the gradient, we can either use y equals mx plus c or y minus b equals mx minus a. For this one, we don't have the y-intercept, so it's going to be best if we use y minus b equals m brackets x minus a. Then you choose one of your points, whichever one you think is going to be most straightforward to substitute in. So I'm going to choose to use D, which is 3, 100, and I'm going to relabel that A and B this time. So we're going to have y minus 100, so I've just replaced B from here, equals m, which is 20, brackets x minus and 3. So tidying that up, we're going to multiply out the bracket first. So y minus 100 equals 20x, and 20 times negative 3, which is minus 60. And last little step, we just need to carry that 100 over. So we're going to add 100 to both sides. Add 100, add 100. Y equals 20x plus 40. And don't forget that if it's in context, you're probably going to write it not in terms of y and x, but in terms of other letters. So y in this context is w. So what we're saying is the weight equals 20 times, instead of x, is a. So the weight equals 20 times the age plus 40. And then often once you've got the context, you're asked a part B. So we're just going to look at this now as well. It says, use the equation from part A to estimate the weight of a 1-year-old calf. Show your working. So copying over what we've just worked out, the weight equals 20A plus 40. Now use your equation in part A to estimate the weight of a 1-year-old calf. So we've been told the age. We've been told that the age is 1, which means A equals 1. So now on the next line, we're going to write the weight equals 20. Instead of A, we're going to multiply it by 1 plus 40. 20 times 1 is just 20. Add another 40. Weight 60 kilograms. So we're estimating that the weight of a 1-year-old is 60 kilograms. Right, and that's a little bit of your straight line in context. So you can maybe look at some other past paper questions and try some of your own now.